we're already partially through. I want to add one more science comment, too. The decadal survey, Mars Science Laboratory is not purely a Mars mission. I mean, Mars Science Laboratory, as Mike said, actually is a planetary science mission. It's much broader than just that. It's geology, it's geochemistry, there's geophysics, a little bit, astrobiology. It covers a lot of disciplines. Mars is the only place in the solar system that actually can fulfill, in an easily accessible way, all of the decadal survey goals for scientific exploration of the solar system. So, pitting Mars community against the rest of the planetary community is really inappropriate. And so if you separate this as, well, Mars is the little community that we're serving, it's really inappropriate. It's just not an appropriate characterization and not an accurate characterization.
Maybe one additional thing, as long as we're adding additional thing, and it's not only the only mission.
Me on something?
Sorry, no, I'm adding.
Oh, okay.
It's not the only mission to Mars. NASA recently selected MAVEN, which is also a mission which will be launched in 2013.
Okay, we got a telephone question now. I think it's Frank Mooring from Aviation Week. Frank.
Thank you. This is for Ed Weiler on the initiative with the European Space Agency. Could you tell us a little bit more about how that's going to proceed? What sort of time frame you're working to for a sample return mission? And also, could you just refresh my memory on where the idea of caching out of Mars Science Lab and also the ExoMars rovers stands right now?
Yeah,
Thank you.
I'll leave the last 3 or 4 or 5 parts of that question to Doug. You start with the cash business. Okay. Yeah, it's easy to talk about what we talked about yesterday because the idea was born in July and it was solidified yesterday. No, there isn't a lot of meat on the bone other than David and I at the top of our 2 science parts of our agencies have agreed that we got to keep fooling ourselves. Nationalism is great. It's nice to put our logos on our missions. But these missions are getting complex and expensive. We have the same scientific goals. They want to send rovers to Mars. They want to do a sample return. They want to search for life. The goals, not surprisingly, Western Europe and the United States seem to think alike when it comes to science on Mars. Isn't this the right time, especially now, considering that the 2016 mission ideas are now up in the air because those missions will be impacted. ESA has some ideas for a mission in 2016. We could probably do a heck of a lot better mission if we did it together than if we continue to compete with each other. We've got technologies and know-how that they don't. They've got technologies and know-hows that are special. Let's work together. What a thought. And this just solidified. We kind of reached the decision without much thought. It was kind of a no-brainer yesterday as I reflected to David what we were about to tell you today. What was the second part of the question before the cash business?
There was an MSR timing question.
Oh, MSR. David and I are both realists. We recognize that scientists like to say missions will cost X, and then by the time the engineers touch them, they're X times 2, and then by the time the cost analysts get involved, it's X plus 3. A sample return mission is not going to be done for $3 billion or $4 billion. That's like saying JWST could be done for $1 billion. When the experts look at a sample return mission, the number comes out to between $6 and $8 billion. That's a lot, and that's not surprising considering what our rover is going to wind up costing. Remember, the rover goes and lands on Mars. That's hard enough. But a sample return mission, we've got to go to Mars, we've got to land, we've got to have a rocket that takes off. It's got to rendezvous with an orbiter. It's got to give it some samples. Then it's got to get to the Earth, and it's got to land safely. Other than that, it's a piece of cake, right? This is going to be a significant mission. And the way to plan a mission like that is not saying, it's going to cost $3 billion. Go do it. That's certainly one management style. But hope and luck is not a management tool, as Mike likes to remind us on many occasions. So David and I both agree that this is probably in the range of $6 to $8 billion to do it properly with the proper testing and technology program before we do it, and that we ought to do it together as a U.S. Western European mission. And probably looking at the kinds of budgets we might expect, considering the economic situation in the world right now, it's probably in the 2020s, early 2020s, is the best we could probably do. But we think that's a realistic date with a realistic cost. And you want to take the cash question?
Yeah, I'm going to expand or add to a little bit of what you just said internationally. There is a very strong global Mars exploration community already. There's an organization that's been in existence for 6 or 7 years called the International Mars Exploration Working Group, which is managers from around the globe at my level that meet every 6 to 12 months to strategize how missions can work cooperatively together to expand the scientific knowledge of the planet. We have very good relationships with Europeans on Mars Express. They've supported Phoenix for us. We've supported them in certain things. We have missions that have, we share instruments all the time. So that global community works pretty well already. That International Mars Exploration Working Group a year and a half ago chartered a group called IMARS that reported back to the EMIWIG, as we call it, who study international Mars sample return. So this move that Ed and David put together to actually expand the cooperation, we've already got a phenomenal framework of cooperation at the engineering and management level globally for Mars. We had 12 nations in that organization that all wanted to participate, and it's been quite spectacular. So I think that the underpinnings politically and socioeconomically are already there. So this works well. And the common goal is sample return. Globally, the common goal is Mars sample return. And we all know we can't get there by ourselves, so we're going to keep that going. That moves us clearly to cache. The cache. There was a cache that the previous associate administrator asked us to put on MSL. It was built. The guys and gals at Ames Research Center did a nice job and delivered us the hardware. Many of the things that we have learned about Mars from Phoenix and handling samples from Phoenix showed that we actually needed cleaning tools for our sample systems on MSL. So there's very little real estate, even though this rover is huge. There's very little real estate left when you look at observation trays and spare drill bits and where the arm can actually reach and see. We needed the space that the cache was taking up for a cleaning system for our sample handling. The other is the science community has evaluated this, and it's certainly unclear that the way the samples were going to be handled were actually going to support the astrobiological needs of the community and where the program Follow the Water and hunting for habitats and things is going to take us. So the cache is no longer on MSL, and it will not be. I know that's going to be the next question, so I'll just say it won't be added back on because we're not going to add things back to this mission at this point in time. The question also included ExoMars. We offered this cache to the Europeans about a year and a half ago, and because of the storage techniques and also a real estate problem on ExoMars, they declined that offer. And so there's little chance, I believe, that ExoMars will have a cache of any type. The mid-decade missions in the 16 and 18 time frame in the process of moving towards sample return, however, that as well as precision landing and improved sample handling and coring are some of the key technologies we want to put in place. But those will be cored samples, they will be hermetically sealed samples, retrievable sample qualities to prove that we can actually do that. So I think those are all the questions in that list.
Okay, we're still on the phone bridge now. We've got Rachel Cortland from New Scientist next.
Yeah, hi. I was wondering whether you anticipated that adding the brushes would impact your schedule at all before you decided to delay, or whether you were expecting you'd be able to sort of to push it under and get the rover set for a 2009 launch.
We didn't hear the first part. Could you repeat the first part of your question, please, Rachel?
I'm wondering how 11th hour your decision to add the brushes was, and whether you're expecting you'd be able to make a 2009 launch with the new brush requirement.
Yes, it was a late discussion or late decision. It was actually, it came out of, as I said, what we found out about Phoenix on the surface, which, as you know, just recently the mission ended. And we learned a lot over the summer about the soil consistencies and handling of those soils. So we had the Phoenix team get together with the Mars Science Lab sample handling and processing team to look at lessons learned from that, and that's where that requirement came from. And I believe that meeting was probably in the October timeframe. It's a crucial piece of equipment. It's fairly simple, we believe, but that design is actually being built or designed right now. It should have no effect. We didn't think it'd have an effect on the 09 launch, and I still don't believe it would. Because it's an externally mounted device. It doesn't have motors or anything in it to the best of our expectations. And so it should have no effect on the 11 launch either, which I think was the tail end of that question.
Okay, one more